Okay, welcome to another lesson where we'll be looking at integration of things such as sine, cos, e to the power of x, and yeah, so things that we have covered for differentiation. So we know what the derivative of sine x is, cos x is, e to the x is, or e to the power of 3x, or ln x, and sine 5x, for instance. That was covered in differentiation. Now we want to work backwards, integration. Now before we start, I think it's probably important to know that the differentiation is going down. When we differentiate, it's going to get us the velocity, but obviously we want to get velocity back to be the displacement function. We would integrate. Notice they're the reverse of each other. So I will probably start with a little bit of differentiation first, just to cover some of the things that we need to differentiate. We've seen this before. So when we do differentiation, let's write differentiation first. So for instance, if we have a function such as y equals sine x, to find the gradient function, we would differentiate this, which means that dy over dx is equal to cos x. And when we have y equals cos x as the original function, the gradient function is going to be minus sine x. And then if we have y equals e to the x, it is just itself. Now if we have here y equals e to the 3x, which is the same one as one before, well, we need to differentiate. Well, we need to use the chain rule where u is 3x. So if I differentiate 3x, it's going to be 3. So here, it's going to be 3e to the 3x. I'm just using the chain rule there, okay? Another one. How about if it's got a number inside? Well, y equals sine 5x. Well, we know what the sine x is. We differentiated, and that is going to be cos x. So here, dx is going to be five cos 5x. And we've also got one special one that we mentioned, or we covered. Y equals ln x, natural log. The derivative of that is 1 over x. Just in case, I'll throw this one in. How about if it's y equals ln 3x plus 5, where it's a modulus because we can't have a negative x-axis? Well, you'll be using the chain rule. We would let u equals 3x plus 5, and y would be ln u. The derivative of ln u, which is ln x, is going to be 1 over u. The derivative of du over dx, which is that, will be 3. So if I were to apply it, dy over dx using the chain rule, so that will give us dy over du times du over dx. Remember, the du will cancel, but notice we already have what dy over du is. It's 1 over u. So that will give us, we've got 3 times 1 over u, which is u is 3x plus 5. Replace it back in, 3x plus 5. Is the answer to what the answer should be for the gradient function. So 3 over 3x plus 5. Notice if I were to integrate this, this will then take us back to here. But if I integrate this, this will give me a ln 3x plus 5. We need to take the derivative integral of this So that means to be 1 divided by 3 divided by 3, so that's why the 3 cancels out. And that's obviously, and that's the answer. That's just an extra one. Right, now we go to integration. So that's the reason why I wanted to start off with differentiation, just to give you a bit of what it is going down the way. So if we want to go back the way, then integration is the opposite of that. And then remember, since this is an indefinite integral, that means we will have a plus c at the back. And if it's a definite integral, the c doesn't matter, because the c will cancel, remember. So integration. So what happens if I integrate, which is the opposite of doing differentiation? So if I had cos x dx, well, notice that going back the way is going to be this. So you can see that way the integral of cos x is going to be sine x, and then plus your constant. Of course, we could have a constant at the back. Notice that if I were to differentiate this, it will be cos x, and that's how we get it. Right, then this one, notice that it is kind of like a reverse. So roughly speaking, I remember myself, oh wait, if I now differentiate that, sine x is cos x, then cos x is going to be minus sine. And then if I go cos x, and then go, and it's the flip version here, cos x goes this way. So if I have a sine x, this is going to be a minus cos x. And then obviously we have the plus c. Roughly speaking, I remember what sine x cos x is, and then I remember that cos x will then give me a minus sine x, and this then will be the flip version. So if I go back, this will be sine will give me the minus, cos will give me the plus. That's the way I remember it anyway. Right. Well, with the integral of e to the x, nothing happens. It's just the self, as you can see. So obviously that will be ex plus c this time. Now what happens if it's the fourth version? Well, if it's the fourth version, let's just say, I'll give you another one. If it's the integral of 3e to the 3x dx, well, notice that we will integrate the 3x. Well, no, when I say integrate, it's not really integrate. Here is what happens with the 3. The 3 here gets to become divided by that number. So it'll be e to the 3x plus c. So if I told you that, let's just put another example here, e to the 4x dx, then the integral of that will be 1/4. That's what I did just now. You see that 3, that 3 and divided by that 3 will cancel. So here is what just happens. You notice that it is mostly just dividing. It's like the power rule. Yeah? It's just like the power rule, except the power doesn't go, the power doesn't change. It stays. So the 4 just comes down as division. And then you see that this is also the case when we do cos x and sine x as well. So for instance, let's just say we have cos 5x dx. Well, notice that if I were to do this with differentiation, it's timesing to the front. Well, since I'm doing the integral, it's going to be 1/5. Now we know what the integral of cos x is. The integral of cos x is sine x. So there is 1/5 sine 5x plus c. So that means that if I were to do the integral of sine 3x dx, this will be the minus of, let's see, 1/3 cos 3x plus c. And roughly that is all that you require to cover the bits that we need for further pure. And these are just some of the questions that come up. Yes, again, there will be a worksheet that will follow this, so I would suggest you try it. I will go over a couple more so that you have a bit more idea of what integration of these terms are. So let's just start with an example, and I will post this in the classroom. Right, example 1. If it's the integral of dx, well, what number is really here? Well, this number is actually a 1. So what's the integral of 5? Well, if it's an integral of 5, then we'll get 5x. So if it's the integral of 1, it'll be just x plus c. Excuse me. Right. Example 2. Feel free to pause the video and have a try first. 7 sine x dx. Well, what's the integral of sine x? Well, the integral of sine x is minus. So that number in the front doesn't change. It stays there. So it'll be minus 7 cos x plus c. Example 3. How about if it's the integral of 9 sine 3x dx? Well, we know that the integral of sine x is minus, okay? So we would have the 3 coming out to become a division. So what's 9 divided by 3? I'll just write a little bit more steps so I can show you what's happening. And then 3x stays as it is. So it'll be minus 3 cos 3x plus c. That's what happens. Remember, when I did the exponential one, that number became a division. Here, if there's a sine 5x, it became a differential in the front. And then the same with this one. It's 5 divided by 3 divided by 4. Roughly that's what's happening with the integrals of these types. So let's keep going. Let's do one with cos now. Example 4. So here we have 12 cos 4 veta, d veta. Notice here up before was x with x. Here is veta, so that's why it's veta. What is the integral of cos? Well, the integral of cos is sine. And what happens with the 4? Well, 4 becomes the division. What's 12 divided by 4 is 3. So be 3 sine, and then 4 veta doesn't change, that's all, plus c. Let's keep going. Example 5. How about the integral of 7 cos 5x dx? Well, the integral of cos is going to be sine, so it's positive sine. Remember, the 5 comes down, it will be divided. 7 divided by 5, we can't cancel, that's why this one doesn't do anything. We have 5x and then plus c. Right, so how about if it's exponent, well, we can do one more. Example 6. So what happens if it's the integral of something like 4 sine x over 3 dx? Well, remember that is just simply 4 sine 1/3 x dx. It's just another way of them writing it to confuse you. I've never seen this come up in further pure, but I'll just stick it in. What happens with the 1/3? Well, 1/3 divided, it's going to be divided, so it's going to become timesing of 12. We're going to times it. 4 divided by 1/3 is going to be 12. So, and then we have the integral of sine x, and that's minus, and then cos, and then you can have it as x over 3 again if you want, and then plus that constant. How about if it's something like 4e to the minus 7x dx? Well, I did say that the power comes down, so it'd be minus 7. So it'd be minus 4 over 7e to this minus 7x, doesn't change, plus c. Example 8. How about if it's 9e to the x over 4 dx? Well, here it'll be just 9 divided by 1/4. 9 divided by 1/4, which will give us 36. E to the x over 4, that power doesn't change, plus c. And then we do one more. So what happens if it's example 9, integral of minus 5 cos pi x dx? Well, remember, if I had 5, if this number was here was a 6x, I would divide it by 6. If it's a 3, I would divide by 3. Here it's just pi, so I'll divide it by pi. What is the integral of cos x? Well, remember the integral of cos x is sine x, as you can see here. So, but notice there is a minus in the front. So it'll be minus 5 over pi cos pi x plus c. No, wait, I forgot to change it. It should be sine. Apologies. Sine pi x plus c. And that is some of the integrals that you would need for the pure. I will see if I can find a couple more questions as to guide you. So here is another couple more. This is exponential. Example 10. The integral of something like, this is a bit beyond, no need to, but I'm just going over it. How about if it's e to the x squared dx? So if this was the question, remember we will differentiate this and then divide it by that derivative. So what I've done here with the 3 here, when I differentiate this part, it's 3x. Well, no, when I differentiate 3x is 3. And then here should be here. When I differentiate this 3x, it's going to be 3, and then we would have that 3 become a denominator, so be 3 divided by 3. That's what I'm doing here. What's the derivative of 4? Well, if a derivative is 4, it's going to be 4, so 1 divided by 4. I am doing the same thing. What is the derivative of x squared? The derivative of x squared is 2x. And I'm dividing this thing inside by that, so it'll be 1 over 2x. And then once I've got that, it's e to the x squared plus c. And that's all I'm doing here. So I'll give you another one. As I said, I don't think you need to go this far, but I thought I'd do a couple more. So what happens if it's the integral of 2x ex squared dx? So what would happen with that? Well, notice the power is still x squared, so that thing here that I've done is still here. Remember, I'm going to divide it by 1 over 2x. So this is going to be 2x divided by 2x, so it's going to be cancelled. So it'll be ex squared plus c. Let's do one more of this type. As I said, we don't need to do anything. This is probably more in IB questions when you get it later. Right, how about if it's 2x cubed ex to the power of 4? Dx. Well, I'm focusing on the ex power 4, so the x power 4 is going to be that. We differentiate dy over dx, it would be 3x cubed. Notice that this is what I'm going to differentiate or divide by to get the answer. Notice I'm always doing that to the exponential power first. So if I were to do that, it will give me, let's see. Something's wrong. Let me just double check. I know why. Should be 4 here. 4 comes down, x cubed. Okay, that's better. Right, so 4 comes down, x cubed. We are dividing this whole thing with that, what we got. So if I were to write this in a little bit more detail, 2x cubed divided by 4x cubed, and then after that, that's it, the process done. We just need to simplify now. Notice that x cubed and x cubed cancel. 2 divided by 4 is going to be a half e to x to the power 4 plus c, and that is the answer for what the original function was before we when we differentiated it. Notice that you can go backwards. Okay, if I were to go backwards, maybe 4x cubed, and then times it by that, which will give me the original function. And is there anything more I want to talk about within this video? I think that covers most of it, but give me a minute, let me see. How about if it's something like, let's see, give me a minute. Question 9a. Yeah, I might do one more or two more. Again, I don't think you'll be asked this, but it's just, as I said, extra questions. How about if it's the integral of something like, minus 6 sine 3x plus 2 dx? Well, first of all, notice, as I said, the number in front, we will have to, this is what is happening when I do the integral of 5x. I'm just doing that 5 here. So the 5, when I differentiate 5x, it's just 5. When I differentiate is the 3x, is 3. So divided by that. When I differentiate 3x plus 2, it's going to be 3 again. So it'll be 6 divided by 3 is 2. Now, what is the integral of sine x? Well, the integral of sine x, as I mentioned, is this minus cos. So we have a minus with a minus, so that means this is going to be a plus. 3x plus 2 plus c. And and that's the answer. We have the answer constant because it's an indefinite integral. So how about if it's this one? Let's see. Again, as I said, you're not going to be asked something like this, but I thought I'd just chuck it in. How about if it's x cos x squared dx? Well, again, we would differentiate this, so that would be 2x. Whatever that is, divided by that. So it'll be x over 2x. Now, what is the integral of cos? The integral of cos is sine x squared plus c. So the x and x will cancel, be half sine x squared plus c. And then let's do another one, just the final one. Let's make it end up on a nice number, example 15. What is the integral of 3x cos x squared minus 7 dx? Again, we would differentiate this, so derivative of that would be 2x divided by that, so it would be 3x divided by 2x. What is the integral of cos? Is sine, so no need for the sign change. X squared minus 7 plus c. It looks like it's going to be 3 half sine x squared minus 7 plus c. Yes, and that's the answer for that final question. Hopefully that will help you when we do a bit of integration of the further pure questions of these type. As I said, there's not too many, so I don't have much on this worksheet, but they're in the classroom of what you will be asked if they do ask it. You can see that this is how many I've got from all the years that further pure has started. Okay. Anyway, thanks for watching, and I'll see you in the next video.